Hi, everybody. I hope you're all doing well and that you've had a wonderful weekend. You've had some time to rest and relax to get yourself ready for the last few weeks of online learning. So, the purpose of this video is really just to give you some review for the work you're going to do this week in stats. So, what I've done is I have copied and pasted your agenda for this. We're already in week 5, okay? And here's what you're asked to do for your final project. You're going to revise any comments on your Google slideshow. A lot of you have already addressed your comments, but if you haven't, if there are suggestions, I would take a look at that and revise them as needed. And then what we're going to quickly go over is how we are creating our histograms, dot plots, and scatter plots, a quick refresher on how to interpret, and then linear models and how can you find all of this with potentially no calculator at home. There's some wonderful online resources, and I will talk a little about them. So, first thing that you're asked to do is you're going to be asked to make histograms and dot plots. You see how here, do you see how it notes that it's one variable graph? So there was a lot of confusion here. So what this basically means is that in these graphs, both of your variables aren't going to be graphed. So as an example, we're going to take a look at our example project where we looked at the average age of an NBA team versus the number of wins they got in a specific season. So for your histogram and dot plots, you're not going to be comparing the two. Instead, what you're going to be doing is creating one for each. So as an example, your histogram will either be age or wins, okay? And your dot plot will be the other. So if your histogram was age, your dot plot's going to be win, okay? So for your histogram and dot plot, your x-axis will be your variable, okay? Will be either age or wins or whatever you're studying. And then your y is going to be the number of times that happened. So as an example, let's say we were making our histogram and we're at an average age between 24 and 25. If 5 teams had that, we would make that bar 5i. We kind of see where we're coming from now with the one variable graphs. Your y isn't your other variable. Instead, it is just the number of people or items that fit that category for the variable. Okay? And then for the scatter plot, it says 2 variable graph. So your 2 variable graph is where you are comparing your variables. So in this case, because we thought that age was the independent variable for our scatter plot, our independent variable will be on our x, and our dependent variable will be on our y. So for the example project, that would have been wins. Okay? So I just wanted you to note the difference between the two. And then real quick, here are the 4 things that you need in order to get a 4 for your graphing. You need your axes to be labeled, you need to have a title, your graphs need to be clear and accurate, and you need to have a consistent scale for both your x and y axes. Okay? And then, once you make your graphs, you're going to be asked to interpret them. Okay? You're going to be asked to interpret all 3. So for your histograms and dot plots, there are 4 things that you need to include: the shape, the center, and the spread, and outliers. Okay? I'm just going to quickly touch base on all of these. So what shape is? Shape is it skewed? Is it skewed left? Is it skewed right? Or is it symmetrical? Okay? I think you all were pretty confident with that. If you have questions about that, please reach out. And then center and spread. So now center and spread can be one of 2 things, okay? And it's dependent on your shape. So we know that when shape is more symmetrical than skewed, for our center, we're going to use mean, and for our spread, we're going to use standard deviation. We do this because when our shape is symmetrical, it fits the normal model better. And when that happens, the best data to use would be mean and standard deviation for center and spread. However, if our shape is skewed or not symmetrical, our center is going to be median, and our spread is going to be our 5-number summary. you want to make sure when talking about how you chose your center and spread, give a reason why you chose what you did, whether it was mean or median. That's what separates you from a 3 to a 4 for that indicator standard. Okay, so really make sure that you're doing that. And finally, the last thing that you're going to need to do to interpret your graphs for your histogram and dot plot is just tell us if they're outliers, and if there are, where. Okay? And then for your scatter plots, it's very, very similar, except it's similar and different at the same time. So what you notice in both of these, we have outlier. Same thing. Are there outliers? And if so, where? And then now let's go through these 3 topics. Okay? Direction. Okay? Your direction is asking you whether or not the relationship is positive or negative. So, based on your slope, when you go ahead and do your linear model, that will tell you the direction, whether it's positive or negative. Then for form, we know it can be one of 2 things. It can be linear or it can be a cluster, okay? So you want to be able to recognize the differences between the two. A cluster is where the data is all over the place and there doesn't really appear to be a connection, whereas a linear graph shows the data more linear and closer together. And then lastly, strength. Strength is how closely related our variables appear to be statistically, and this is something, what we're going to use to find strength is correlation coefficient, or R, okay? And because correlation coefficient relates directly to linear models, because when we used our calculators in class, correlation coefficient was given with linear models. So I understand that some of you may not have calculators at home, and that is totally fine. The easiest way to do this, if you don't, is to Google linear model calculator, and I just took a chance and Googled it, and I looked at the first 4, and the first 4 references were all great. What it's going to ask you to do is to plug in all of your X variable data and then all your Y variable data, and it will output your linear model. The one thing that I would tell you to be careful about with your linear model is notice this form, y equals a plus bx, where a is our y-intercept and b is our slope, right? The one thing I want you to be careful about, in some forms, they switch these. Okay? So where they have y equals ax plus b. And then those ones, a would be our slope and b would be our y-intercept. So make sure you pay attention to where they're putting the x, because the variable attached to the x is going to be our slope always. So please, please, please be careful when identifying your linear model to make sure on whatever you're using is that you are using the right variables. So I really believe that this is all the refreshers you need to go ahead and do week 2, or this week 2 of our final project. If you have any questions, please reach out. I would love to set up a time with any of you to work on this and just to hear how you all are doing. I hope you have a wonderful week, and I will talk to you soon.